Still, there's a rush of coming in. Present now. Enter screen. Then, yeah. Yeah. So let me come in here. These are the problems of directional derivative. One or two problems of directional derivative I'll do. Then come to the divergence and curl. So let me introduce the directional derivative. Can you see it?
No, sir.
Oh, acha. But I have projected this. Can you see it now?
No, sir.
No. Okay. Then what to do?
No, sir, we can't see.
Okay. Then what can I do for you? So I have shared. Okay. I have shared, but I am not getting it. Why?
Sir, once you can restart and rejoin.
I'll try one thing. Present now. So I have present now. Your entire screen. Then I am just presenting. Can you now see it?
No,
No,
sir.
sir.
Now you have to select the small window and click on share.
Oh, acha. Okay. Small window.
Yes.
I share your entire screen. So share. Small window is there.
Yes.
Oh,
Click
acha,
on that.
share. Uh, I think now you have got it.
Yes, sir.
Yes,
Yes,
sir.
you have got it.
Yes, sir. Yes.
Okay. So directional derivative. That is very important. That I have discussed you last time. I'll again show it the diagram. That diagram is here. Gradient. Acha. This is the diagram. So suppose this is the vector V. I want the component of the vector along P. P is another vector. I want to take the component of the vector along P. So there is some effect. Vector is here, but there is some effect here. So I want to find out this effect. This is called directional derivative. So component of V along P is V, which vector you are taking, then along P will be P vector by modulus of P vector. That is a mathematical notation. So let us come to this problem. Problem number 10. Problem number 10. So they are asking for find the directional derivative of the scalar point function f x y z is x square by x square z square at the point 1 minus 1 minus in the direction of AB. So please follow that they are asking for the directional derivative of this function. This is your V, I have shown you. At the point this, in the direction of AB, this is your P, where B has a coordinate this. So let me solve it. That okay. let me solve it. Say f is x square plus x square plus z square. So del f is, del we know, this is the del operator, I del x plus j del y plus k del z of x square plus y j x y plus z square. It comes to this one. 2x plus yi xi xj plus 2zk. At the point A means I'll put the point 1 minus 1 minus 1. So if I put 1 minus 1 minus 1, then if you put x is equal to 1, so it is yes 1. That is this is y is minus 1, yes, 2 minus 1, so it is only 1i. If you put y is equal to minus 1, x is equal to 1, y is equal to minus 1, z is equal to minus 1, you will get this vector. And you want to convert this vector along this direction. AB is the desired direction. That is, AB is the, you want to find out the component of the F along the vector AB. So how to find out AB? That is position vector of B minus position vector of A. So find out this. This is 2i plus 3j plus 2k, and unit vector in the direction of AB is this vector divided by unit vector, you know, the vector divided by modulus of I modulus of A, that is 2 square plus 3 square plus z square is equal to, calculation is like this, 1 by root 17 2i plus A. So the required directional derivative is this vector into unit vector p by p bar. You remember p by modulus of p. You remember that. So it is I plus j minus 2k into 1 by root 17 this. So this result is this. So you will be able to find out the directional derivative. Now someone is waiting, coming late. Oh, some two. Achha, okay. But this is the last year. What can I do? So many times. Okay. Next problem. Please come. For the function phi is xy by x square plus y square, find the magnitude of the directional derivative. I'm sorry. What it is? Problem number 10. Yeah, 11. Now I am searching for. Find the magnitude of direction derivative along a line making an angle 60 degrees with a positive x-axis at 1, 2. So I want the vector scalar function along this line AB. So del phi. First you find out del phi. Del phi is del, you know, I del s plus del y plus k del j of phi. That is xy by x square plus y square. So after calculation, you see that I del x of xy by x square plus y square comes to y by x square plus y square minus 2x square y by x square whole square. Plus partial derivatives with respect to x. First you take u by v method. U into differentiation of v minus v into differentiation of u. So this is the u v method. I just, this is easy for you. U into v method. U by v method. So that is after differentiation you come this for j del y of xy plus a square whole square. So it comes like this, and j, and there drawn you the vector AB will be find along this. I component of I is half I, component of j is root 3 by 2i. So at the point del phi, at the point 1, 2, they have mentioned that point. Let's see, 1, 2, at the point 1, 2. So you put it, here it is, put 1, 2, you get this into unit vector, that is p by modulus of p. You just remember, first time I have shown you. So after making dot product, you will get this. This is the magnitude of the derivative, directional derivative of the vector along AB. So this is the directional derivative of the vector along AB, right? All right, everything convinced? Just follow the tactics. I cannot show you all this because this time restriction is there. I have to convert to the divergence. What is divergence? I have to convert. So for this reason, I will show one more two problems more. Someone is again come. Okay. Okay. What is? Yeah. Okay. Find the maximum value of the directional derivative phi at the point 1, 2, 3. Find also the direction in which it occurs. Okay. So our function is scalar point function is given as x square plus y square plus z square. So del phi, I'll have to find del phi. So I del x, del is like this, x square plus y square plus there's some misprint, I think. It should be z square. So at that point 1, 2, 3, they have mentioned point is 1, 2, 3. So put 1, 2, 3 here, you will get the del phi 1, 2, 3. And since the directional derivative is maximum in the direction of del phi, you know, last time we told, in the direction of del phi, directional derivative is maximum. Therefore, the required direction is this is direction 2i plus 4j plus 6k, and also the maximum value is modulus of this, that is equal to 2 root 40. So another problem quickly. 13. Okay, 13. Find the maximum rate of change of phi. This is the scalar point function at 1, 1 minus 2. Point is given. Phi is xy square plus y square z y square x square y z square. So del phi is this much. And at the point 1, 1 minus 2, this comes to 9i plus 6j minus 4k. And so maximum rate of change occurs in the direction of del phi. That I have discussed last lecture. You have to note this point because maximum rate of change will be in the direction of del phi. So its magnitude is del phi. This is the direction, and magnitude is magnitude of the vector root over 9 square plus 6 square plus minus 4 square. It comes to root over 133. So all these problems we have to find phi, del phi, and then if they ask for a directional derivative, you have to find out the unit vector, that is p by modulus of p. Just remember, so this can be done this way. So just follow these other parts. There are much of problems. Shall I come to the divergence? Because all this problem, this is your homework assignment. I'll tell you. This will be your assignment. Okay. This one, suppose at any random selection I have done it. So find the directional derivative of phi, which is x square y square z square at 1 minus 1, 1, in the direction making an angle, equal angles with the positive x, y, z axis. Okay. So our phi is x square y square z square. Del phi is this much, 2xy square z square I plus 2y x square z square j plus 2z x square y square k. So at the point 1 minus 1, 1, this is 2i minus 2j plus 2k. Let A be the unit vector. You have to multiply with the unit vector. A be the unit vector making an angle, theta with the positive, because you have some liberty that it is making the angle theta with all the axes, x, y, z. So this unit vector is I cos theta plus j cos theta plus k cos theta, because unit or angle with all the axes are same. So this is unit vector where cos square theta plus cos square theta plus cos square theta is equal to 1. This is the 3-dimensional geometry that the coefficients of this I, j, and k, if you square and add it, it will be 1. This is the solid geometry. So, or 3 cos square theta is equal to 1. So cos theta is equal to plus minus 1 by root 3. So a unit vector is plus minus 1 by root 3 I, j, k. Right? Because cos theta is plus minus 1 by root 3. So put here that unit vector is A is equal to plus minus 1 by root 3 I plus j plus k. And so the directional derivative will be how much? Directional derivative will be this del phi 1 minus 1 1 into what? The unit vector which I have prepared, plus minus 1 by root 3 I plus j plus k. Can you following me or any difficulty? Any difficulty? Because nobody is
No,
responding.
sir.
Oh, yeah.
No,
No,
sir,
sir.
it's okay.
Okay. If you know the methodology, problem will be figure will be changed in the examination. Don't bother about it. You take that. So if you know the process, that is your benefit. So required directional derivative are this dot into the unit vector which I have prepared, plus minus 1 by root 3 I plus j plus k. So they have written here and comes to the directional derivative is plus minus 2 by root 3. So there are other problems also. You have to this will be an assignment. You will be practiced. That's a benefit. You will practice. So let me come to the. Please permit me to go to the divergence. What is called divergence and what is called curl. That I want to discuss today. The problems will be. Yeah, problems will be in the next class. So presenting. Yes, I am presenting some other slides. Verses 7. So the other slide. So here it is coming. Please see divergence of a vector point function. Divergence of vector point function. What is that? Let f be a vector point function. You know what is vector point function? So f is a vector point function of x, y, z, and it is continuously differentiable. Assume that is has to be maintained. It is continuously differentiable in a certain region R of the three-dimensional space. In the divergence of f, or it is written as div f. Okay, divergence. All the long term is not written. It is called div f or del dot f. So div f means divergence of a vector function is del dot f is what is del I del f del x. Oh, after the calculation it is coming like this. Del is I del del x plus j del del y plus k del del y dot this f, that is coming, result is coming as I del f del x plus j del f del y plus k del f del y is equal to sigma form, sigma I del f del x. And so divergence is defined as a vector point function, and the result is a scalar quantity. And the result is a scalar quantity. Okay, in the problem we'll see it is a scalar quantity because this is the sum. In f there is some I, j, k is hidden. After the calculation you'll see that it is only a scalar quantity. Another point. If C is a scalar constant, then del of Cf is equal to C can be taken out, del dot F. And if F is a vector I F1 xyz plus J F2 xyz plus K F3 xyz, then del dot F is equal to I del will be written as I del del x plus J del del y plus K del del dot F is written as I F1 plus J F2 plus K. After this dot product, we will get this much del f1 del x plus del f2 del y plus del f3 del z. So this is the divergence. And f dot del will be, if somebody asks you to do it, f dot del, then the result will be this. And one more point, important point. So please remember these things. I'll send you this literature, no problem. But what I've told, please remember that divergence is del dot f. or divergence F means del dot F, and it is after calculation it will be a scalar quantity. Okay. Then one most important point is Laplace operator. You may have heard this name, Laplace operator. Deepak Kumar, too late. Why? Laplacian operator. Laplacian operator del square is defined by del bar square, that is equal to del dot L. It is nothing but del dot L. That is why it is called del square. Is del is I del Lx plus j del y plus k del z dot again I del x plus j del y plus k del f dz is coming as del square del x square plus del square del y square plus del square del z square, and in sigma form it is this. So you may have heard this Laplacian operator. This is your Laplacian operator. So what this is called del square del x square plus del square del y square plus del square del z square is called Laplacian operator. This quantity del square del x square plus del square del y square plus del square del z square is called Laplacian quantity, Laplacian operator. In the problem there is the Laplace operator of this scalar quantity is this. Then don't be confused. Laplace means del square del x square plus del square del y square plus del square del z square. Okay. So phi is a scalar point function and f be a vector point function, then del square phi is equal to del square phi del x square plus del square phi del y square plus del square phi del z square, and del square f is del square f del x square plus del square f del y square plus del square f del z square, right? This is called the equation del square phi. If it is 0, this is known as Laplace's equation. If del square phi is 0, then it is called Laplace's equation. What is Laplacian operator and equation is different. This is called Laplacian operator. Del square del x square plus del square del y square plus del square del z square is Laplacian operator. And if del square phi is equal to 0, then it is known as Laplace's equation, and it is called, and any of its solution is called harmonic function. In complex, there is one term, harmonic function. Somebody may have done it, but I don't think everybody know it. Harmonic function has some special property. I will not discuss about harmonic function right now. So this is the operating system. Harmonic function. If del square phi is equal to 0 is known as Laplace's equation, its solution is called harmonic function. Now, divergence of grad phi, what will happen? Divergence is del dot grad phi. Okay, divergence and then grad. So divergence is del dot f, but f is here grad phi. So you write del dot phi. So it is del square phi, and hence divergence of grad means Laplacian operator. Clear? No? Yes, my boss, this point is to be noted. Divergence of grad is equivalent to Laplacian operator. And solenoidal vector. Solenoidal vector, a vector point f is called to be solenoidal if divergence of f, in the problem will come, divergence of f is 0, then it is called solenoidal. If divergence of vector point function, that is del dot f, is 0, then it is called a solenoidal function. In the examination paper, they will be asking prove that this vector is solenoidal. If you do not know what is solenoidal, you cannot answer it. But if now you know what is solenoidal. If divergence of f is equal to del dot f is equal to 0, the vector f will be called solenoidal. And vector f is broken into ijk form, this one. And so for solenoidal vector, divergence f, that is del f1 del x plus del f2 del y plus del f3 del z is equal to 0. So before coming to the curl, I want to show you some diagram that is what is actually called divergence before going into the curve. I'll come back. Okay. This is the figure because I could not able to find more better picture because the lighting problem was there. So it's enlarged a little bit. What is divergence? That is, suppose from this wall, I am indicating my arrow. Can you see it? Can you see it? So this
Yes.
space. Okay. Then suppose some velocity is there in this space. This one, arrow is given. This one, some velocity. Water is flowing. Think about the water tunnel, and suppose this type of a rectangle, and suppose v is a velocity at this space, BC PA. This is the velocity at this space, and velocity at PC PN is delta y plus y. Sorry, Vy plus delta y. Here it is Vy, and the other face it is Vy plus delta because some change in the velocity. Because either it will be velocity fluctuating, always it is not 30 km/h, not like this. In this box, in this phase, what is the velocity? Anything else, say 30, here will be 30.2. So there is some difference. And what is divergence? If this velocity vector is unchanged, that is, what is the velocity here? Same velocity when it is coming to the other face, then it's called divergence is 0. So nothing is speeding up. See what is going with some velocity. At the other end of the box, it is not increasing at all. Suppose same delta V, then divergence will be 0. So nothing is inflating. Divergence means nothing is inflating the system. That is called divergence. Suppose here at this phase the velocity is 30 km/h, and the other phase the velocity is 40 km/h. So that means that something is taking place in between the rectangle. So some abnormality or anything else. Maybe many things else, because there some slope is there, because some other points are there. Suppose there is a thrust from a stone is thrown. That is why the velocity is increasing. And if it is increasing, it is 30, here it is 40, then means something has happened inside the box. And so, if something has happened, then so divergence is non-zero. So divergence of f will not be equal to 0. If nothing has happened, whatever is coming here smoothly, that quantity is coming in the other plane. That is why they have discussed in, you cannot see the literature. So this is why they discuss. So whatever the velocity here and the velocity other is same, then nothing has happened inside the box. So this divergence will be 0. If nothing happens inside the box, then the divergence is 0, and that is called solenoidal vector function. Now in divergence, you will be given the problem, solenoidal vector function, and if we have to just check out whether divergence is 0. If the divergence is 0, this is called solenoidal vector function, right? Everybody is convinced with this. Any understanding problem or anything else? No.
No, sir.
So
No,
I am
sir.
clearly discussing you that what happened. So mathematically divergence is 0, non-zero doesn't mean anything. It means anything. Problem will be all right, but you will never know what is the concept of divergence. But from here, I'll again come back to the curl. I just closing this and opening the other one. Okay, curl of a vector function, vector point function. Have you understood the divergence? Yes or no? Somebody respond me. Yes,
sir.
or no? Okay. Just remember this picture.
Yes, sir.
Just remember this. At this end velocity, the other end velocity is same. Then it is solenoidal vector and divergence is 0. Okay. That is why it is written solenoidal. But you are, if you do not, I do not explain you, you will not understand. You know the name solenoidal vector, you will not understand it. Okay. Curl of the vector. Suppose x, y, z is a continuously differential vector point function defined in certain region. Then curl of f is defined as curl f, or somebody tells it rot f. Somebody prefers to write rot. Somebody prefers to write curl, something like that. So it is nothing but in the divergence is taken, then del dot f. But if curl is taken, then it is del cross f. That's all. This is the difference. Dot and cross. This is the difference. Dot, and in case of curl, it is cross. So I, after expanding, it is I cross del f del x plus j cross del f del, because they are taking the cross product, plus k cross del f del j, that is sigma in summation form. And curl is a function of vector one function, and the result is a vector quantity, because you will take the cross product, it will be vector quantity. Divergence, what was there? Last page, it is a scalar. Divergence will be a scalar. But curl will be a vector quantity. C is a constant, then del cross CF, some constant is disturbing you. You cannot take del plus 5f. So suppose C is equal to 5. Then you have to just take out this C, and it will be C del cross F. Understood? Can be taken out of the bracket. This is permitted. And del cross F will not be equal to F plus del, it will not be equal to del cross F. This you have to remember. If you take a del cross F cross del, that is a bit different. If you take del cross F, it is also different. So those will not be equal. Never. And if F is equal to I, F1 x y z plus F2 is this, then curl of L can be determined. I have done some problem with the help of curl in the last lecture, but that time I assume that you know this, but actual picture is this. You have to remember the picture. What happened? This a vector F is there. IF1 plus JF2 plus K. And curl of F we are taking, that is L cross F. Divergence is del dot F. Curl is del cross F. This is the prime difference. And del is I del x plus j del y plus k del z cross F. F is IF1 plus JF2 plus K3. So what you know this technique of finding the curl, that you don't have to multiply side one is to another, I del x of I F1, nothing like this. You can do it. Result will be same, but easy policy is this. Just first row you write IJK, second row you write del x plus del x del y del z. Third row you write F1, F2, F3. Please remind this. Please remember this. This will be remembered by you for rest of your BTech degree. If you don't know, you will be stuck up at various points. You have to often you have to take the curl. So what can I do? This, when curl of this vector cross this vector is, please remember this techniques. I am going slowly. That is why. So I, J, K first row, Second row will be this one, del del x, del del y, del del z, del del x, del del y, del del z. Third row will be the coefficients, f1, f2, f3, f1, f2, f3. So after breaking, I del del y of f3 minus del del z of f2, okay, plus j del del z of f1 minus del del x of f3, right? Then next one, determinant expanding. Determinant expanding, you have done so many times. K del f3 del x, as yes, del f3 f2 minus del del y f1. So this will be the result, curl f. And if A is a constant vector, then it will be, curl will be 0. Because there is no ijk or anything, there is no ijk, then the result will be 0. And next term, see, got it point, got the point. What is curl? Got the point. Actually, curl is the whether a vector is going straight or vector is spinning. That is judged by curl. That is, if curl is 0 means this is straight vector, no spinning. You know cricket ball, spin ball. So spinning means vector itself is spinning. That is not, if curl is 0, it is not there. It's not spinning at all. But if curl is not 0, something else, then it is spinning somewhat. Again, I am coming back to this. Coming back to this picture. This can you see it? Okay. So this vector v1 is coming in, but if curl is 0 means, if curl is 0 means it is not spinning. Curl 0 means it's going straight. v1, and here v1 plus delta v1. So if curl is not 0, then this vector is spinning itself, and the result will come here. Okay. If v1 is not spinning at all, going straight to the other face, then it is, curl is 0. Okay. Then I think coming to this point, yes, irrotational vector function. That is, you have to, in the examination, what they'll do, so that this vector is irrotational. Then you have to know irrotational means you have to take curl and make it 0. That is what. If you do not know the term irrotational, then you cannot answer it. Most of the boys or girls, they do not listen very carefully, and so if the examination are, so that this vector is irrotational, they don't understand how to do it. But I don't want to do so. I am doing it, saying you very clearly. I can give 20 problems one day, that will not benefit you. You know the basic things. Okay. Suppose, for example, the vector point function is this: x plus 2y plus 4z I plus 2x minus 3y j zj 4x minus y plus 2z k is irrotational. Since, let me find out what happened. So first row is I j k, as I told you. Second row will be del del x, del del y, del del z, not difficult. Third row will be x plus 2y plus 4z, and then 2x minus 3y minus z, then 4x minus y plus 2z, right? So then simplify it, and the result is coming as 0. That is why it is irrotational. No spinning component. It is not rotating. That is why it is, the curl will be 0. No, there is no other thing. Vector is coming straight, or it is straight, or with some spins. Spin ball means itself it is spinning. So vector, whether it is spinning or not, the vector will tell you. After calculation, you see that this vector is 0. So there is no spinning component. Got this point? Okay, this is very important point that
Yes, sir.
okay, then the problem will come important identities. That is, if see this is, I don't have to discuss it. Some identities may have to use in the problem. Grad A plus minus G is equal to grad A plus minus grad G. Divergence of A plus minus G, divergence. I have just learned it 5-10 minutes back. Is divergence of A plus minus divergence. You can separate. If the divergence of two vectors are there, you can separate in the separate vectors. Divergence of A plus divergence of G, and curl A plus G will be curl A plus minus curl G. So it is permissible for addition. If some two vectors summation take divergence is equivalent to divergence of the first vector plus divergence of the second vector. And curl of A plus minus G plus G, suppose, then it will be curl A plus curl G. So this addition and subtraction is permitted. There are some identities you have to remember. You don't have to prove never. You don't have to prove. Only you have to know in case this arise. Grad F is A grad G plus G grad A is easy to remember. Once you read, there is no problem. Grad F G is F curl G plus G curl F plus F dot del G plus G dot del F. This occasionally used, not used continuously. Divergence of F cross G is equal to G curl of F minus F curl of G. This is used sometimes. Divergence of F cross G is G dot curl F minus G F dot curl, and curl of F, curl of L plus G is a big problem. F divergence of G minus G divergence of F plus G dot del F minus F dot del G. This is for if sometimes by chance it is equal to, they will assume you know this. Okay, then others are there, it's the same thing. And second order properties, no proof. You don't waste your effort for proving this. Just you have to know curl of grad A is 0. Divergence of curl F is 0. Curl of curl F is grad divergence F minus Laplacian. Laplacian you know del square. Del square Laplacian means del square F. So these are the, we will get done this note, no problem. I think I have sent it. No, I have not sent it. Okay. And never try to prove it. Now, a few problems. And the problems I come into this. Today it will not be possible to finish. Okay. Some problems. Find divergence of a, starting from a simple one. Not the first time I don't go to the complex one. First, we'll start with simple one. That find divergence of F and curl F, where F is grad. It is coming 2 times in the Macau examination, 2001 and 9. There's a chance of coming this year, I suppose, because there is long gap. So grad of x cube plus y cube plus z cube minus cx y z. So F is this. So calculate first F. F is written in complex form. So first F is equal to grad x cube plus y cube plus z cube minus cx. So what is grad? You know del. Sorry. Yes. Del this function. Del means I del x plus j del y plus k del a. So I del x of this one plus j del y of this one. Grad, I don't repeat it because grad is discussed in the last class very well. And j del y of this plus k del y of this. So result is this. So this is your F. Correct? Correct. Say no. Say no. You are asked to calculate only divergence of it. So F is not given. F is grad phi. Grad of this. Grad x cube plus y plus z cube minus a cube. So do it. Grad means del. Del of this one. X cube plus y cube plus z cube minus 3x y z. And expanding I del x plus j del y plus k del of this. So result will be this. Now we take divergence because they are asking for divergence. So divergence of f is del dot f. I have just 5 minutes back I have discussed del dot f is the divergence. Del cross f is the curl. So del divergence of f is del dot f I del x plus j del x del of dot this. Because f is this 3x square plus cyz I plus 3y square 3xz j plus 3z square minus 3xy k. So now you expand, sorry, I dot I is 1. So del x of 3x square minus 3yj. Following this, here it is I del x. Here it is 3x square minus 3yz I. So I dot I is 1. So it is coming as del x of 3x square minus 3yz. Then similarly, the second one, del y of this, you will get not difficult at all. Del y of 3y square minus 3xz plus del z of 3z square minus 3xy. And result will be just take a partial differentiation 6x, then it is 6y, then it is 6z. So 6 is common. So this is your divergence of f. It is a scalar quantity, is it not? I have discussed this point that divergence is scalar quantity. Del dot f is scalar quantity. And del cross f will be vector quantity. And now they are also asking for curl f. Curl f is del cross f. Again, writing position is same. Don't never make a mistake to directly find out this. It's easy process is this determined. First row will be ijk, second row will be del x, del y, del z, and third row will be coming to the vector. Yes. Third row will be 3x square minus 3yz. Yes. Similarly, 3y square minus 3xz plus 3z square minus 3x, and that is equal to this one. This is the curl of this vector. And 0 because a curl is 0. The reason is that this minus 3x and this 3x will be cancelled. And this minus 3x is cancelled. So it is only a 0 vector. So this vector point function f is irrotational or not? Please answer. Curl is coming to 0. So whether it is irrotational or not. Somebody answer it.
Sir, irrotational.
Is it?
Irrotational.
You said irrotational.
Irrotational. Very good. Because after working out, I have found that curl f is 0. So there is this irrotational vector. That is, the vector itself is not spinning, straight vector, right? So one more example.
Sir,
Just
we
one
have
more.
already class from 12:30.
One more. So that this vector is irrotational. Find the function phi such that a is del phi. Okay. It is came 2 times, 2002 in Macau, 2002 and 4. So Yes, your answer is okay because you understood what is curl, meaning of curl. First part, so that the vector this is irrotational. So for that reason, I have to curl of A. That's printed this wrongly. That is del cross A. Cross. Curl means cross. So first row will be ijk, second row will be del F, del y, del z, and third row will be this vector 6xy plus z cube, 3x square minus z, 3z square minus k. So find out this. So after calculation, fortunately I found that this is zero vector after calculation. So this A is irrotational. This type of problem comes often, whether equation, whether solenoidal, etc. etc. Second part, A is equal to del phi. So they have told you assuming is equal to some del phi, and therefore A is this vector 6xy plus z cube plus 3x square minus z plus k, and right side will be del phi del I del phi del z del phi del y k del phi del z. And equating the coefficients of ijk from both sides, you see del x will be very easy. Del x will be del phi del x will be 6y plus z cube, right? And del phi del y will be 3x square minus z, etc. And so d phi will be del phi del x into dx plus del phi del y into dx plus del phi will get into dx. After random calculation, you will get d phi is equal to this 3d of x square y plus 3 plus d of x z cube minus d of y z. So integrating means only phi. So 3x square y plus x z cube minus y z is equal to plus c, integration constant. So this much is found out. This is required scalar function. Actually, this is Thompson's method. They have not told you. Thompson's method, if you want to find out phi, you have to take this result. D phi is equal to this, and apply this one. And whatever is finding out, you will get this. And after one integration, we will find out this function. But Thompson's method. But you don't remember, but working is you will remember. Thompson is a great mathematician. So if you want phi, what you have to do, d phi is equal to del phi del x dx plus del phi del y dy plus del phi del z dz. After all this calculation, just take a integration. This will be phi. This will be the function required. C is a constant because the integration constant is there. Can't help it. Note. Here A is conservative, irrotational vector field, and phi is on the scalar potential. Right? Other problems will be discussed in the next class. So, if anybody have any doubts or anything, just tell me. Okay, then I have found the assignment for almost all of you, but a few are didn't submit. Please, because this will be evaluated for your internal mark. I found about 5 they did not submit the assignment. Please submit it, because if you do not submit, then I cannot give you the marks for assignment. Whatever you understand, you just write. Okay, but if I do not find anything, any response, then I'll have to put it 0 for the assignment section. Don't, please avoid this. I think those have not done it. Please submit it. So next class, the other problems of the vector calculus will be discussed, and after that I'll come to the integration part. That is integration. Now this is all the way the differentiation, all the things. And integration is another process that I'll have to discuss in the next class, because next class some other problems are there that I'll discuss, because only to find the irrotational vector checking and solenoid is not thing. Other things are there that you have to practice also. So examiner's mind. I can only guide you, but examiner's mind is the final thing. What they'll set. Okay, thanks.